Dear students, now we are going to discuss about adaptive beamforming, least mean squares, samples matrix inversion. So now, the first we are going to discuss what is adaptive beamforming. So this adaptive beamforming uses an antenna array to enhances a desired signal while suppressing interference and noise by adaptively adjusting the complex weight vector. So here, so what is adaptive beamforming is, suppose maybe this is your device. So here you need to direct your antenna array to maybe this direction. Okay. So now how to enhance your desired signal means you have to form the main beam toward this thing, and we have some side lobes and everything. So that thing you need to do nulling effect. You have to suppressing these types of interference by nulling effect. So whether you need to remove this. So here also, so only you are allowing that main lobe only to the desired signal. So that is the, so we have, so the antenna we have, so these types of side lobes, that is that thing only here they mention as interference. And now what you have to do means you have to suppressing the side lobes, and you are allowing only the desired signal towards this direction of angle of arrival. So how you can do this, and how you are doing this, enhance the desired signal. So like that you have to enhance your desired signal. So now the next part is how to adjust the weight vector. So for that, we need to know the signal model. So for an array of m sensors, we have a of theta s plus s of n plus summation of k is equal to 1 to k, a of theta k, ik of n plus v of n. So here your output, see here that you need to take Hermitian of this weight of x of n. So by that we can easily optimize the performance criterion. For example, if you want to know the minimum mean square or maximum signal interference noise ratio, everything we can easily find. So based on this adjustable weight vector, we are enhances our desired signal. The next thing is least mean squares beam format. So here that LMS is the gradient based adaptive algorithm. So what is the main purpose of this algorithm is it minimizes the mean square error between beamformer output and also the reference signal. So here the reference signal, so what training signal you are used, so that thing you have to take it. The next thing is error signal C, how to find. So you have to find the desired signal minus that we are generating no signal model, that value. So based on that, you have to calculate the cost function. The cost function is nothing but you have to take the ensemble average of your error signal. The next thing is we need to know, we have to generate the weight update equation for every step size. So here see the W of n plus mu x of n e conjugate of n. So here where the mu is nothing but learning rate, that means step size. For each step size you need to update your weight equation. So this is the normal LMS update algorithm used to adaptive beamforming. See here we have x naught to xn minus 1 and omega naught to omega n minus 1, y of t, d of t, and e of t, d of t minus y of t. So now based on that we need to generate this least mean square update algorithm. So here there is a weight function on, based on the weight function it will be automatically adjust to generate our desired signal. And what are the properties of this adaptive beamforming? This means squares. So here the first thing is low computational complexity. That means we can easily compute based on that modulo method. The next thing is monometric inversion here. So based on that only here we mention as low computational complexity and low convergence. So depend on the eigenvalue, we are easily do the spread of covariance matrix, and then also it requires the training signal. Next thing is, see here, this is the fractional least mean square method. So that detailed diagram previously we have discussed. So based on this date function, this FLMS processor easily processing and finding your error signal and enhances the desired signal. Thank you.